Hey guys, it's Bill from Linden, Tennessee. So welcome to the mess that I'm calling my couch on this Saturday before Labor Day. Hope you're having a good Labor Day weekend. So I made some stuff at work. This is probably going to be a multi-part video for the weekend. So I made some stuff. I drilled some holes, made a little plate, got me a shaft, got some bearings. This is my position sensor for my steering wheel. So what's going to happen is at one point my steering wheel is going to be about right here, and then this mess here is going to mount inside the console of the tractor. And on this end, there's a square drive end there. That's what's going to go in my rotary damper to give my steering wheel some feel. That's the plan anyway. That is our gigantic actuator we've met before. Here is a motor controller, and here is an Arduino. This is actually not an Arduino. This is an Elegoo, L-E-L-E-G-O-O, but the O-O is the Arduino symbol. I think it's just a knockoff. It's a cheap knockoff, but it works really good. The other one worked pretty good until I let the smoke out of it when I put negative to positive and positive to negative, and then it stopped working, and I couldn't figure out how to get the smoke back. So fortunately, I know myself, so I bought two, and this one worked good. My buddy Collin Kidder, he's a really super smart guy when it comes to computers and lots of stuff, really. He wrote me some Arduino code. I'll put a link in the description. There's a guy on YouTube that put some code together and shows how you make a Arduino control a linear actuator and have it return, not so much return to position, but just stay in whatever position you put it at. It'll be up to me on my steering column to make it actually snap back to center. I'll have some sort of a spring situation or something. I don't know how I'm going to do it just yet, but anyway. Yeah, anyway, so this, if I turn my little steering shaft, you can see all these numbers go crazy. See? Numbers going crazy. And what that's doing is on the left side you have, on the right side of that you have the command. So that is it says minus 55 right now. I don't know minus 55 of what. That's probably some sort of a logarithmic value or something. I don't know how Arduinos work. If it wasn't for Collin, I'd be scratching my head or trying to come up with something else. But and then on the left side is actual. So that's what the position sensor of the actuator is saying it is. So we come over here and I steer the wheel to the left. By golly. Now at some point I'll have a thing that says that'll be the center, and I'll steer left and it'll snap back to center, and I'll steer right and it'll snap back to center. So that's it. You know, it's just a hairball mess of wires sort of cobbled together just to see how this thing works, that it does work. And it does work, so that was easy. Yeah. So, right. We'll see you next time. Hey guys, back again. Kind of pulling an all-nighter tonight after sitting around on the couch all day and not doing anything. I decided to come on out to the garage about 2 hours ago. Started looking at where am I going to put this actuator. Oh yeah, about the actuator. So I made that video, showed you how awesome that thing works. And then I stopped the video, started messing with it some more, and all I did was unplug the USB from the computer and tried to cycle the actuator again, and it fried the voltage regulator on the Arduino. I don't know. I had noticed the voltage reading on the power supply that I was using was fluctuating. It was spiking up when the actuator stopped. I saw it get into like upper 20s, 25 to 26. The Arduino can only handle about 20, and even with that it's probably struggling. So if for whatever reason the actuator was causing a power voltage spike, that's most likely what it was. Maybe it's a power supply, and it won't do that on a battery. I don't know. So I ordered 2 more of them, and we'll just have to see. We'll have to see what happens next time. So anyway, yeah. So came out here and tried to figure out where it's gonna go, and man, long story short, it's going right there. That's where it's going. This was kind of a pain in the butt, kind of, because there's a lip down there, and then there's this one here. This is that piece that I welded on to extend the frame up higher. Well, I had to obviously notch the top part of the frame, but I also had to notch the bottom. I got this little piece of 1/4 inch Luan, 3/16 Luan on there, just to sort of space it up off of the bolts there on the transmission. But yeah, and then of course I had to notch the frame here to make room for my block that I made. Oh, my block that I made! I made this block. This thing is pretty cool. I'll have to get a better video of this when it's not installed, but I called the boss, and he let me in the shop after hours to, well, yesterday on Saturday, to give me access to the mill so I could make that block. So basically I just took a solid chunk of aluminum and bored a 2-inch hole in it, cut it in half, and then drill and tapped and counterbored some 3/8 bolts through the side there. And yeah, that took about 4 hours. But yeah, I really appreciate him letting me do that. So some of the mandatory tools that you need when you do a build of any kind, I suppose, but certainly an articulated 4x4, but an electric car or anything, you need angle grinders. You need at least one. I've got like 3. And you really need a welder, and you don't really need a plasma cutter, but when you do need a plasma cutter, man, you really need a plasma cutter. Like those bottom flanges, there is no other way to get it. There's no other way to get them out of there. I don't know, hacksaw maybe. I don't know, sawzall possibly, but not without moving the transmission out of the way. Everything that had been in the way. The plasma cutter was really the only way to get them out of there. So when you need it, you really, really need it. And access to a good machine shop, preferably one that has machines that you can use, because every once in a while you're just going to need to machine some parts. And I bought this little lathe, and I don't know, for the first 2 or 3 months that I had it, I thought it was stupid, a waste of money. But boy, I've used this thing a lot, just to make, little simple little brackets, little spacers and collars and just things. I did a lot of work on that drive shaft, on that spline drive shaft with it. The lathe itself isn't really big enough to fit that shaft in there, but it'll hold the end of it, and then you can use a live center on the other end to keep it from flopping around. Anyway, but yeah, I've used it quite a lot. So yeah, machine tools, very, very handy. Otherwise, you're just going to pay a machine shop to do it, which is fine. You can do the same thing with a welder. Of course, I suppose you could pay someone to do the entire thing. Anyway, yeah, so that's where we're at. So tomorrow, well, I don't know. I can't really do much more than this. I got a guy drawing of a coupler that's going to go over that. It's just a piece of aluminum, round stock aluminum that's got a 1-inch bore on one end, and then it's got just a through hole on the other end, so it'll slip over that. A pin will go through here, and then this will bolt to that coupler, and then this is just a smaller version of that. So this will be a rod that goes across, and then I'll make a bracket over here that I can't really make until I have that, because I don't know exactly where it's going to land. But yeah, so that's how that's going to work, and I really hope it does work. I think it will work. It should work. Why wouldn't it work? One thing that's kind of a bummer is the distance between this center line of thrust right here and the center pivot is about yay much, about 3 inches. It'd be nicer if it was more, but that's what I got. So that's what it is. That's a 560-pound actuator, and this, it's being held solidly by this block that I made, and it's, also got a little bolt back there too, a little block back there that's bolted to the frame. So I mean, that part's not going anywhere. That's a very solid mount. And then this one up here, I'll just make it long. It'll basically be kind of like a triangle. It'll sort of come up and around, and then it'll have a hole in it too, like that. So it'll come up and around, and then down, and then probably come back, you know, maybe 6 inches or something, and then it'll bolt in like 4 or maybe 6 places. But the longer that I can make it span across there, the more load that it can take, because there is going to be quite a bit of force on that actuator. So anyway, that's kind of where we're at. So some good progress tonight. It's after 10 o'clock. So anyway, thanks for watching. We'll see you next time.